Alright, let's look at how to solve this equation algebraically. As you can see, there are going to be multiple steps to solve for x in this equation. So the first thing we do is we start with the general equation. In this case, 5 equals 9 plus 7 cosine 2 pi over 13 times x minus 4. Now, since we're trying to solve for x, we need to move through everything that's blocking x from being on its own. So the first thing we'll do is subtract the constant term c, 9, and we'll get negative 4 equals 7 cosine 2 pi over 13 times x minus 4. The next thing in our way is the 7, or the amplitude a. So we need to divide by 7 on both sides, and we'll get negative 4/7 equals cosine 2 pi 13 over x minus 4. And now we can see that the next thing blocking us from x is the cosine operation. And here's where we get to take advantage now of what we've been discussing, the inverse or arc cosine. We're going to take the arc cosine of both sides to remove the cosine, since the arc cosine is the inverse of the cosine. And when we take the inverse function of a function in a composite manner, we end up with just the x value. So I'll take the arc cosine of both sides here. And as we can see, the arc cosine and the cosine will cancel each other out, and we'll be left with just the expression inside the cosine, 2 pi over 13 times x minus 4 on the right, and the arc cosine of negative 4/7 on the left. Now we have the 2 pi over 13 blocking us from the x, so we're going to multiply both sides by 13 over 2 pi, or the reciprocal of b, which leaves me the 13 over 2 pi times the arc cosine of negative 4/7 on the left. The next step we're going to take is to replace the arc cosine expression with its definition. Remember how we said that the arc cosine was equal to plus or minus the inverse cosine of negative 4/7 plus 2 pi n, to take into account those coterminal angles, or the periodic nature of the cosine function. From here we're going to replace the inverse cosine expression with its numerical value. If I take out my calculator and ask for the inverse cosine of negative 4/7, I will get 2.1790. So I replace that value of inverse cosine negative 4/7 with 2.1790. Don't forget to leave the plus or minus here. The next thing I'm going to do is distribute the 13 over 2 pi across my expression here on the right. So 13 times 2.1790 gives me 4.5085 after I've divided by 2 pi. 13 over 2 pi times 2 pi is 13. Don't forget to distribute those values to both the initial term and the periodic expression. The final thing we need to do to isolate x is to add the phase displacement of 4 to both sides. And we get 4 plus or minus 4.5085 plus 13n equals x. Now this expression here allows us to calculate any solution for x. So this would be a great final answer if I'm simply trying to find an expression for all the possible values of x that meet the requirements of our initial equation. If I want to find particular values of x, then I'm going to split this equation, because there's a plus or minus, into two statements, one for the plus and one for the minus. So on one side, I'll have 4 plus 4.5085, which gives me this 8.5085 plus 13n equals x1. And then If 4.5085 is negative, and I add 4 to it, I get negative 0.5085 plus 13n for a second set of solutions. To find particular values, I simply choose values for n and simplify the expression. So if I chose values of negative 1 for n, and then 0 for n, 1, and 2 in my plus side expression, I would end up with the four values negative 4.4915, 8.5085, and 21.5085. If I added another 13, I would end up with 34.5085. If I choose these values for n on the minus expression, I end up with the values of negative 13.5085, negative 0.5085, and 12.4915, and 25.4915. So by substituting those integer values, I can find specific values as solutions. So algebraically, we could make the statement that x is 4 plus or minus 4.5084 plus or minus periods of our function.